Good afternoon. I'd like to welcome all the schools in the Bering Strait School District to our Mentor Lecture Series. This is the third one of the year. And the title of this lecture is Journey to the Permafrost. We are happy to have Dr. Yoshikawa from the University of Alaska Fairbanks to join us this afternoon. He is an Associate Research Professor in Water Resources. Dr. Yoshikawa comes to us from Tokyo, Japan, where his interest in science can be traced to his high school days. He recalls exactly to the day, July 21st, 1976, when he saw a Martian landscape image on the front page of a newspaper. And if you were to look up this date, you would find that the NASA's Viking 1 lander made history by descending from orbit to the surface of Mars. This left a strong impression on him and led him to an immediate attraction to Mars and a goal of understanding the Earth system. So after graduating from high school, Dr. Yoshikawa went on to college and graduate school to pursue his interest in the study of permafrost. Through his education and interest, he has made several expeditions that included crossing Greenland, travel to the South Pole, the Antarctic, crossing Sahara, and many other adventures. While working on a subsea permafrost project in 1994, he obtained his sea captain's license that would enable him to set sail from Japan to Alaska via the Russian coast in a 43-foot ketch, a steel hull sailboat, equipped with subsea drilling operation and monitoring permafrost. His journey ended near Point Barrow, where he lived for 2 years before moving to Fairbanks in 1997 to work at the University of Alaska Fairbanks. So without further ado, I present you Dr. Yoshikawa, who can tell you more about his interests and studies of the permafrost around the globe.
Thank you. Good afternoon, everybody. My name is Kenji Yoshikawa. Mary introduced me about I'm originally came from Japan. That's why I'm looks Japanese, right? Then I have a little problem about speaking English, not like native speaking. But I hope you can understand what I'm talking about. So today, what I wanna say, I want to talk about permafrost, especially if the permafrost thawing or if permafrost something changing, what happened in the world. Just we will try to explain about this. Okay, first things, maybe I should mention about why I'm originally from Japan, grew up Tokyo. Tokyo has no permafrost, very warm place compared with Alaska. The why I'm moving to Alaska and study permafrost, I just quickly introduce by myself. This picture, upper one, is a black and white picture. This is a Martian surface about 30 years ago. NASA took. This is the first picture. Humans see the Martian surface. You see that this is looks like we see the sky. Looks like somewhere in middle of desert in Earth. When I was high school, I saw this picture. I really very impressed. Oh, it looks like somewhere middle of desert. I really wanna go there, if possible. Then I wanna go to Mars. Then what I should do? What I should prepare for to go Mars? Then end up my solution is something. I become scientist, study something related to Martian environment. That's how I try to do this. Then I decide to study permafrost. Permafrost because all entire Martian terrain has a permafrost. And if I become a specialist about permafrost, maybe in the future I have a chance to go there. That's this picture is a very important picture for me to decide. Then end up now I moved to Alaska because Alaska is much convenient to study permafrost compared to in Japan. But I'm here then since 97, about 10 years ago, I started working UAF, since then, I very like to live here and study permafrost. So then this is some of the picture I can show you the permafrost terrain, the Martian surface. This is a south, almost near South Pole on Mars. You see the kind of patterned ground. I hope you can see. This picture very similar like this. This is near Kotzebue. Maybe you can see this kind of pattern when you are from airplane. They call it ice wedge polygons. This is very much like patterned ground naturally. What happened is this is when the winter time ground is very cold and freeze, get shrink. The ones that shrink, they have a crack between the soil. Then springtime, all the snow melt water filling the permafrost, then refreeze. Then that happened 1,000 time or 2,000 time, meaning like 1,000 years, 2,000 years, very long time. We can develop these kind of patterns. These patterns are exactly same like here you can see in the Martian surface. The same kind of stuff we have in Earth, like Alaska, also Mars. So when the underground, this is one of the picture of Fairbanks under the mining tunnel. You can see the ice, middle of triangle shape. This is the ice wedge ice. These we saw above the ground the ice wedge polygons. Same things on the Mars. So then when you look at the solar system, the permafrost is kind of very popular. This is a image picture from Titan. Titan is one of the satellites on Saturn system. We're thinking that there is a methane lake and the ocean there, like this. Then, of course, like Jupiter's moon has the same things. We have a permafrost too. I mean, when we talk about permafrost is very popular in solar system. When we live here in Alaska, we are popular too. But when you look at the United States, looks like only permafrost is Alaska things, not for lower 48. But when you look at the solar system, permafrost is very common, even the universe. Same thing is sometimes you can see the comet. This is mainly made by frozen soil and the ice. This is also part of permafrost. So before we go further talk about permafrost, I should talk. We have to figure out the definition of permafrost. When we look at the dictionary, the permafrost say the thermal condition where ground material stays at or below 0 degrees C for 2 or more years. That's the dictionary say the permafrost. But that's kind of difficult to remember, right? Just so you know, everybody remember the permafrost meaning always frozen. Anything frozen, the summer conditions, frozen things, always, even the summer times, that's the permafrost. You don't have to be the ice, or you don't have to be the soil. Even you can see that like anything material, wood or mammoth bone or everything below 0 degrees C, meaning below 30 degrees Fahrenheit, is permafrost. So then now we're gonna talk about a little bit about why we study permafrost, or what do we need to study permafrost? This question, I tried to answer 4 different answers I want to tell you today. The first one, the permafrost is a key aspect for looking for the life in universe. This meaning recently we tried to looking for the bacteria in Martian permafrost. Then so far we don't have any life we can find outside of Earth. But we may find some bacteria in Martian ground. which in the permafrost. I mean, the way we look at the first things, we look at the life in universe. Maybe the looking for the bacteria in the permafrost is maybe more closest distance. I mean, we have to study something about bacteria in permafrost. That's a very interesting topic. Then one of the scientists came from California, study about the bacteria in permafrost in Fairbanks. So this is one of the picture I show you. So this most of the Fairbanks permafrost is established about 30 to 40,000 years ago. Since then, keep frozen, right? But we found some bacteria hibernated. I mean, the bacteria can easy to sleep for 30,000 years. Then we can wake them up again. That we exactly same things we may able to do on Martian permafrost too in the future. So then another thing, so why we study permafrost, that's maybe most important for you and us. So permafrost control local hydrology and the ecosystem. The simple word, permafrost controls almost all our life environment. This meaning usually permafrost is frozen. The frozen meaning doesn't water go through. I mean anything in the springtime, snow melt water or rain water in the summer, or permafrost easily can hold everything. That's why when you go to permafrost region, a lot of lake and pond, wetland, because permafrost holding all water. Then if the permafrost degrade, meaning going thawing, what happens? Something like that, start draining. They end up surface going to drier, no more wet. I mean, maybe you see a lot of tundra and wetland today, but when the permafrost thawing, surface going to drier. That maybe happen the different word. Maybe you like to pick the blueberry or hunting moose or other animals, but if surface drier, maybe some blueberries go some other place, no more grow the different environment. That case, another animal also moving somewhere else. I mean, your surrounding environment is big changing. Just one thing is permafrost thawing, going to big changing. I can show you the little example today about. So I just brought the sand. You can see that sand here. Just dry, thaw sand. I make a lot of poke the sharp things, make whole bottom. Then I put in the water here. Can you see it? You see that lots of water dripping. That's kind of typical things, right? But if they're frozen, I make a put out today very cold outside Fairbanks, minus 40. So I put outside, it's all frozen in here. Same sun, but this is frozen. Then we put the water here. You can see, right? Frozen sand, water doesn't go through. But if the thawed, water dripping, right? That same things you can see on tundra. If we permafrost, water can hold the surface, but if no permafrost, water drain. These things makes a lot of changing in the world, your environment. So then another thing, we worry about the house. Maybe you see similar kind. This picture is from Siberia, Yakutsk, Siberia. But once permafrost thawing, what happens? The house is leaning, or a lot of breaking, or road, telephone pole leaning. We have a lot of surface problem after thawing permafrost. That's also we don't want to have like this. That we want to study permafrost to prevent this kind of hazard. Then last one, I just mentioned another things. thawing permafrost emit a lot of greenhouse gases, mainly the methane gas emit from permafrost. I mean, once permafrost thawing, a lot of methane gas goes to atmosphere, then going to more warming. That's why we want to study how much gas in the permafrost. That's also important topic. So just very simply summarize four things. Maybe there is a lot more we have to worry that we have to study about permafrost, but maybe four things is an interesting topic to me. Then also I want to everybody understand. One, permafrost is very important for the looking for the life in universe. Then second, permafrost affects a lot of local ecology or water cycle in the area. And third, permafrost degradation affects all the houses or road and telephone poles, such as these kind of infrastructures. And the last one, the thawing permafrost emit a lot of greenhouse gases, such as methane gas, to the atmosphere. That's why we want to study permafrost. We want to monitor permafrost. So then what I do is there is some permafrost monitoring site in Alaska, but mainly only at along the pipeline, which is Prudhoe Bay to Fairbanks. We have a nice network, but we don't have much site in the Bering School District and also like Yukon River, because very hard to access. They are very hard to set up. Then somebody has to take care of this, but we can go to take care of everywhere. Then, but these areas more important than the cold region, because maybe next, if permafrost warmer, more impact to the warmer permafrost region, which is near Bering School District. Okay. So then what I'm doing going to the village, make a borehole meaning make a drill hole, then put in the temperature sensor to measure permafrost together with students and teachers. And this map I can show you, this is last spring. I'm traveling by snow machine to start from Manley Hot Springs to the St. Mary's. Mainly I make make hole and monitor permafrost these villages along the Yukon River. Then this spring, that I'm planning to the yellow line, you can see most of the villages in Bering Strait School District. Then I will go to Central Lawrence Island later, different time. But this spring snow machine trip, I will go this way. Start from St. Mary's, go up to the Cotsview. Then I will stop by your school. Then I can see you that time. Maybe we can discuss more detail. So what that looks like, maybe we go to two snow machine like this. This is the last year's picture. Then last year we used a lot of trail share with Iditarod race. I mean, you can see the dog marshes just we pass through. So then what we doing is just to make a hole in the ground like this. Then end up we can make like a pipe stick up from the ground like this. Then inside the pipe, we have a small data logger there. You can see the just very tiny one here. This is one data logger means a small computer. There's 4 different sensor you can stick in. This is a temperature sensor. Plug in, then measure every hour, more than a year we can collect the temperature. 2 of these, we try to put each hole, measure 8 different depths of temperature. So that we plan to do this. Then, by the way, I just wanna show you a little bit about Hawaii. Maybe many of you have been Hawaii, I believe. Then, but Hawaii is in general like a warm tropical island. But there is permafrost. I can show you that Alaska is permafrost is not just Alaska. It's also Hawaii. We have a permafrost. When you go Hawaii Island, that's the biggest island in Hawaii. There is a very tall mountain called Mauna Kea. The top of the Mauna Kea, we have a permafrost. About 10-14 meter thickness of permafrost. You can see that we call it patterned ground. You see the like stripe shape ground surface. That's a freezing process making like this shape. By the way, when back to the Alaska, this is one of our results. You can see the one right side is the Fairbanks Pearl Creek Elementary School, left side the Barrow High School. The both are about 6 meter deep borehole hole, measure temperature. Then we can measure all year round. Then end up like that figure you can see. Then what's most important I want to point out today is permafrost temperature. You can see that go deeper. Oh, sorry, I have to tell you that x-axis is temperature. The y-axis is the depth. Then all the top is 0, meaning surface, ground surface. Then -1 is 1 meter below, 2 meter below, 3 meter, 4 meter, 5 meter. About 5 meter below at the barrow site, you can see the temperature. Then you can tell the near surface, winter time very cold, summertime very getting warmer. But when go ground deeper, temperature doesn't much changing as near surface. They end up in barrow, left side picture, about 5 meter below surface, almost no changing all year round, same temperature, which is about -7 degrees C. Then Fairbanks, right side picture, you can see the summertime more than 10 degrees C, winter time almost -10 degrees C, fluctuated 20 degrees more. But when go ground deeper and deeper, at the Fairbanks, almost 3 meter below, with no changing at all, which is about -0.5 degrees C. What's important is just think about many news or many newspaper tell you about like next 100 years air temperature may rise like 5 degree, or some people say 1 degree, or some people say 10 degree. Just simply more likely, very little, more likely is if the 1 degree C warmer in next 50 or 100 years, ground temperature also rise 1 degree C. Like for example, Barrow, right now -7 degrees C at 5 permafrost temperature, -7 going to -6, 1 degree C warmer. Still Barrow, lots of permafrost, very cold. Nothing really changing permafrost temperature. But Fairbanks, if we have a 1 degree C warmer, right now the only -0.5, meaning 1 degree warmer, going to +0.5, meaning all the permafrost gone. I mean, the Fairbanks, just 1 degree warmer, permafrost is changing a lot, which is surface condition. Remember the like water conditions, or it's going to rain, the wet place is going to drier, all changing. I mean, like warmer place, warmer permafrost may be impact a lot. The same thing as Bering School District is a warmer permafrost than the Barrow, which may affect a lot too. Same things we try to do is a frost tube. What it is, just a simple just tube, clear tube. I put in the colored water. What it is, they just make another hole, put in the pipe like this, stick up the ground. I put in this colored water tube in there. What happens is once the colored water freezes, going to clear because ice has no color in it. I mean, when I set up like this, then lift up the winter time, how deep freezing in the ground you can tell easily. That's we try to set up. Then you can measure every week or every other week. Lift up. Then measure how deep ground freeze. That you can monitor the how affect the permafrost. Then maybe I can tell you how these are important for the permafrost or climatic changing. This is the first signal we can catch using this one. So that we try to the frost tube on the one hole for the frost tube. This colored water. Then another one is for temperature sensor that we plan to put in each village this spring. So the last thing, this is last picture. I want to say just a little bit about important our project. This permafrost, one of the problem about permafrost is a very slow process. Freezing process is very slow, so slow. If temperature warming this spring or next spring doesn't really affect for the permafrost. Permafrost need time to something react, like 10 years, 50 years, finally start changing if something is changing. So that means we need to monitor permafrost a long time. Then we don't really have any long time period yet in Alaska, even in the world. We don't have scientific information about like 50 years or 100 years, how change permafrost. We don't know really yet. Then only one example exists. That's this picture. Left side you can see the old guy. His name is Max Brower. He's about 90 years old today. He was a director of NAR, with Barrow's the Navy Institute. He's director in 1950s. Then what he did a lot of drill hole. You can see the right side small picture. He measured permafrost temperature about 50 years ago. Then that time it's not really people feel important about permafrost temperature. Just he measured lots of permafrost temperature. He published several papers about this temperature, but not many people about feeling something special. But now his data are getting very important because I take him to the Barrow about 3-4 years ago. Then we found several borehole, this holes, but which he did 50 years ago. I clean up again. We measure again. That time we knew about 50 years ago and today how temperature changing. Then end up finally we figure out some of place in Barrow temperature warmer than 1 degree C warmer today, or we have some result. Same things I wanna do at each villages. We try to measure today, meaning this year we try to start measurement, but maybe temperature changing, maybe another 50 years, we don't much changing. That meaning different words, like my lifetime may not changing much, but when you become elder, like 50 or 60 years old, we may changing, but that time I'm not exist anymore. I want you everybody remember the borehole. Then you measure again 50 years later. That case, we can tell the difference now and 50 years later how permafrost changing. That's one of the project I want to do. That's why I want to involve the younger generation to this measurement. So, and this is last picture I want to show you. The earlier Mary introduced me about I like to travel many places in the world. Then maybe I can show you the in us. Long time ago I traveled in the Amazon, the canoe like this. I travel Greenland, crossing Greenland. Then like crossing the Australia. I'm going to South Pole. I'm crossing Sahara. Or like I'm sailing the Arctic Ocean. But what very important things I figure out is here we really had to live in Arctic. You can see that easily. Right? If we go Amazon, you don't really need any clothes. You just need maybe how to catch fish. If you know how to catch fish, you can survive. You can live there. If you wanna go desert, if you have a water, you don't die. But if you don't have a water, of course, a little dangerous. But see the here Arctic, you need to know many knowledge. Otherwise, immediately you can die. So then I really attractive this area because we're so special, so complicated knowledge. All this knowledge came from here. You see that all knowledge is all the your ancestor developed all the surviving skill technique. That's I'm very interested about learn about that. So this is one of the last picture I present today. Right side is me. Left side is somebody in Tuareg in the Sahara's nomad people. So right side you can see the cross. That's mainly the Greenland native people making for me, but really works great for the cold temperature, right? I mean, I strongly encourage everybody learn your ancestors' technique or surviving skill in the cold region. This is very special compared to other area in the earth. I very wanna recommend to learn a skill from elders. Thank you very much.
Oh, how deep of the holes do you dig for the permafrost?
Okay, yeah, thank you for the question. That's I forget to tell you. Yeah, we try to dig about 20 feet, 6 meter. That's for the temperature monitoring, permafrost monitoring hole. Then another one for the frost tube. We try to drill about the area is about 1 meter, about 3 feet, 4 feet. 2 holes each screw. That's we try to do.
How are the instruments powered?
The data log has just a small, like camera battery, same kind of small battery. But this works great. Actually, we have a same one in the summit, top of the Denali, McKinley. We have a 1 year keep monitoring temperature, no problem. That works. The same one right now is almost near the summit of Everest. You know the Everest, world highest mountain, highest mountain in the world. They have the same one, then almost near top, but it still works great.
What do you like and dislike about studying permafrost?
Oh, okay. So I like study permafrost. Mainly, I like to make a dig hole because sometimes very interesting comes up. Sometimes I remember most exciting when I digging ground. Sometimes ice comes up in the middle of summer, very hot, very fun. But sometimes hair comes up, like hair from hole. Then what? I can't understand why I dig somebody's dead body or something I saw, but actually mammoth, mammoth bone, mammoth hair comes up. I mean, we don't know until digging ground what comes up. That's the most exciting part for me. Then dislike, maybe everybody knew about mosquitoes. The summertime work outside, so many bugs. Then that's a little problem, but not a big problem. But yeah, that's I don't like much. Then also, usually when go to tundra, the Tasek tundra, it's very hard to walk. Maybe everybody same experience, right? And I carried a lot of heavy equipment, bring it to the tundra. That's a little pain, but not bad.
How do your travels around the world relate to permafrost?
Yeah, I think I try to save another picture. When I go your village, I wanna show you about another world, like Africa or Australia or South America. But my trip, like I can quickly show you about crossing Sahara. Sounds like nothing related to permafrost, right? But actually, it is related. Then I wanna show you the why I'm go to middle of Sahara, why I'm go to middle of Africa. I'm looking for the permafrost. Then I wanna show you some of the picture about permafrost of this area.
How long does it take you to dig the holes?
That's a good question. Yeah, I think I have a depend on material. If we have a like shield, shield very fine material, it's kind of easy. Maybe we can do 30 minutes. But if we hit the gravel, oh, that's very difficult. When we hit the gravel, takes a day sometimes or more. Then yeah, I mean again, they depend on what kind of frozen soil underneath. That's very much different the time.
What would happen if all the permafrost melted?
Yeah, actually, no, I still don't know much about how much really thawing. First question. That's maybe you hear the many news or many things. Oh, permafrost all gone, Alaska next 50, 100 years. I don't know really. That's why we want to test it. We wanna see ourselves. That's why we try to set up permafrost monitoring site at each school. That's first things. Then if it's something thawing, yeah, I think the vegetation changing. That's a big difference. That must be something big, environment changing. But our history, like natural history, we had a similar situation before. Like about 10,000 years ago, most of permafrost is thaw out, gone. I mean, this is not the first experience for us, but the first experience for us because human coming here maybe about 30,000 years ago, or maybe in Alaska, maybe I would say that 10,000 years ago. I mean, we never have a experience permafrost thawing everywhere, but yeah, I think her question it is maybe changing about vegetation and water conditions.
You commented about the person that in Barrow studied permafrost 50 years ago. When did the study of permafrost begin?
So
when did permafrost study begin?
Yeah, he studies 1948, but he drilled a lot of boreholes in 1952. I still using his hole, which is very interesting. Like more than 50 years difference we can tell, but only the Barrow we have this kind of hole. No other place in Alaska, even no other place in most of the world. I mean, after this project done, if we imagine, each village has a borehole meaning temperature monitoring hole. That case, like 50 years later, some scientist or somebody, or maybe you guys become scientists or you guys become teacher to measure permafrost again. We use this hole, like 2007, 2008, and 2058. We can compare these two, which is very variable. Then I think impress all the country, all the world, scientists or community about how changing. That's why we wanna set up this year.
What made you interested in permafrost?
So what made interest? Yeah, first things remember when I was in high school. Yeah, I went to see the permafrost on Martian surface. That's why permafrost is a good thing. I still wanna go Mars someday, but it looks like my lifetime, it's getting old and getting difficult now. But one good thing is, I had several equipment go to Mars today. I mean, maybe I can go, but maybe I want some projects to participant to bring to Martian project. But anyways, that's your question there. That's mainly my starting point of the why study permafrost, why interest, because Mars. That's maybe starting.
When you sailed from Japan to Alaska, were you studying permafrost and the subsurface?
Right. Yeah, that's actually one of the most challenging. I still wanna keep doing this project. This is a lot of permafrost underneath the Arctic Ocean. Then, Arctic Ocean permafrost temperatures are very critical. Because ocean doesn't freeze, meaning ocean's freezing point is a minus 1.8 degrees C. Then permafrost can thaw out 0 degrees C. I mean, the only between the 0 and the minus 1.8 degree is a difference. I mean, just a little ocean water getting warmer, permafrost all thaw out. That's very interesting topic. That's why I tried to sailing to the Arctic Ocean to get permafrost sample and subsea, because maybe a lot of methane in the permafrost. Same things maybe you heard about the Beringer, right? Bering land bridge long time ago, maximum glaciation. Sea level is much lower, then Siberia and Alaska is connected. I believe many native people crossing the land bridge just walking, right? That means some of the villages still in the long ancient villages now bottom of the sea, under the sea. I mean, when I look at looking for the permafrost in the subsea, if we see some village, if we can find, which is very interesting. That's another interesting topic, the undersea, because sea floor is still a lot of unknown, especially in the Arctic Ocean. That's why I like to study more about subsea permafrost.
Well, you didn't drill holes, did you, or how did you study it? By other instruments?
Yeah, it's the first thing is maybe you heard about the side scan sonar, which is just like aerial photo. You take a picture, dragging the boat to the instrument and taking a sea floor picture first. Then if something interesting future we see, then we wait until winter. All the sea ice come, then drill through the sea ice and the water, then get the permafrost sample from sea floor. That's we did about 10 years ago.
How will you use the information you're collecting? Are you working with another scientist, or is it something you're doing with your studies?
Yeah, there's many things I want to use this data. If we get all village data, first simply I want to I want to tell you, I want to, everybody understand, like, for example, when you become elder, like 50 years, maybe even, 30, 50 years later, you have grandkids, right? Maybe. Then you can explain to your child or grandchild about what temperature is your village, what looks like, what kind of vegetation, what kind of environment your village today. Like 50 years later may change a lot. That time, you can explain to your grandchild about today's condition. That time, if you can specific, permafrost temperature is -2 or -5, something you can tell some specific, which is much better description. That's one thing. So we want to work together. Then for in the future, when you become elder, you can explain about your environment. That's I want to use this data. Then another thing for the scientific community, it is we don't have any data in the village, all the village in Alaska. We established all the data. This is getting a very important data set. Then I will explain to the other scientists, but I'm sure that most of the scientists are interested about the whole data set. I mean, these are works great for the scientific community, but also your local community too.
When you drill the hole to put the instruments down, do you come up with a core sample of the tundra or the permafrost?
That's a good question. Yeah, so I like to quoting them, describe more detail, but limited equipment, also limited time. Then I don't quoting all the way. We just take some sample, then I figure out what kind of material is. Then later, I describe each village how it looks like. But yeah, this time only in general we just drill a hole, then just describe what kind of material. That's it.
You said something about in your talk about bacteria can be frozen. Who studies the bacteria that they find frozen?
Yeah, now the many scientists, especially space biologists, are very interested about permafrost. Some people go to Siberia, get the permafrost sample. Then also in the United States, which is most of NASA scientists, is come to Alaska. Then I help them a lot about giving a lot of different kind of sample that we try to taking then give to NASA scientists.
Permafrost, you say it takes a long time for permafrost to freeze. When you have a warming period like dinosaurs were in Alaska, how low did the permafrost go then? What's the range?
Yeah, I think most of the permafrost about 10,000 years ago, last glaciation started, then permafrost started established. But some of the permafrost is really old, we believe. But the majority is just the last 10,000 years.
What about, is there permafrost on, say, did you go on the Aleutian Islands?
Yeah.
Is there permafrost on little islands like that, or Diomede?
Oh, no. I think, Diomede, yeah, I think so. I never been that Diomede.
But how about on the Aleutian chain?
Only that mountain, high altitude, not in the coastal area, only the mountain.
Well, on top of the mountain. How about in the ocean area around the island?
No permafrost.
No permafrost.
Yeah, then even subsea permafrost. I tried to look for the subsea permafrost around the Nome and Terra, especially Grand Tree Harbor. You can't find it. Maybe more. Yeah, there is a lot of permafrost in Barrow, subsea permafrost in Barrow, but not around the Terra.
What is the difference? It's a little you bore a hole and put that tube in. It doesn't affect the permafrost around it because nothing's being flushed. I mean, I'm thinking
it's actually when we drill, depend on method of drilling. If we use like water, it's going to a little disturb.
Okay.
But settle down about 3 months later, back to normal. But usually we don't use water, which means maybe day or two we go back to the original temperature.
What type of tools do you take with you to do this?
Just auger.
How long? But
auger.
how?
Oh, like 20 feet.
20 feet?
Yeah, you just every 4 feet. Electric power usually. Just connect every 4 feet, 1 meter section, extend it.
So when you're headed out on this trek that you'll be taking this spring, how much materials will you be taking?
Yeah,
say poundage.
Yeah, last spring trip we take maybe more than 1 ton, but we figure that's too much. Then we try to less this spring.
Do you start from here, or you send it all out and start from there? Your starting point.
Yeah, send to St. Mary.
Send to St. Mary's.
Yeah.
We'd like to thank all the Bering Strait schools for joining us today and for listening in on our talk with Dr. Yoshikawa. And if you have any questions, you can write to our ACMP email address, and we'd be welcome to pass them on to Dr. Yoshikawa. Also, he will be in your area this spring, and I'm sure you'll enjoy hearing about his travels. We look forward to hearing from him and from you, and we'll see you next month. Thank you for joining in.
Thank you.